Hello, this is Ghana mathematics teacher. Welcome to Mathematics Gymnasium. Today, we are going to discuss the concept of trigonometry, introduction. Anyway, here is the right angle triangle. A right angle triangle is a triangle whose one of the interior angles is 90 degrees. Of course, we all know that every triangle has the sum of its interior angle to be 180 degrees. So, for a triangle to have one of the interior angles to be 90 degrees is an indication that it's a right angle triangle. Some call it right triangle. They are still referring to the same thing. Now, the implication is that the remaining two angles which are acute are complementary. How do I mean? Two angles whose sum is 90 degrees are complementary, while two angles whose sum is 180 degrees are supplementary. So take note. Having said so, a right angle triangle is the only triangle that has names for each of the sides, the longest being the hypotenuse. Now, the side on which the outline angle aside the right angle rests is called the adjacent, while the side that is facing the outlined acute angle is called the opposite. So, how does trigonometry come? Trigonometry now has to do with the ratio of these sides. If this is over this, there is a ratio for that. If this is over this, then we have a name for that. If this is over this, we have a name for that. Even if this is over this, we still have a name for that. So, the basic trigonometric ratios are sine, because it cannot stand in isolation. The sine of an angle equals the ratio of the opposite side to that angle to the hypotenuse of the same right angle triangle. Cosine is equal to the ratio of the adjacent to the hypotenuse. While tangent is equal to opposite over adjacent. And the acronym designed to make it easier for people to remember is SOHCAHTOA. That is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So these are the basic trigonometric ratios. I call them basic because they are the first point of call when we are discussing trigonometry. The inverse of this still exists. Now let me explain why this is cosine. If this side is outlined, this becomes adjacent and this becomes the hypotenuse. So, or better still, this becomes the opposite to this, and this remains the hypotenuse. So it will now still be a sine. So it's more or less a cosine, just the way you have copilot. So this is a cosine. Okay? Good. Now, when it comes to trigonometry at the basic level, here are a few questions can come up from under trigonometry. Let's say for instance we are doing something like this, and we are going to find the length of the side labeled x in the figure below. From what we can see, the figure under consideration is a right angle triangle. Here we have one of the sides labeled, being the longest side, apparently is the hypotenuse. The other side is labeled x, and one of the acute angle is given. Technically, all the interior angles have been given. How do I mean? We all know that if this is 90, the sum of this and this is 90. So if we subtract 37 from 90, we are going to be left with 53 here. So technically, we have all the interior angles. Now we are told to find this length. In some other cases, we may be told to find this, but it only exists in textbook. In ideal situation, in exam situation, you may only have this. On rare occasions, will you be told to find this and this, and or this. Having said so, the first thing to do is to identify what is the side, the given side called. This is the hypotenuse. This is the side on which the inclined angle lies. So this is the adjacent. Which trigonometric ratio connects hypotenuse and adjacent? It is cosine. So we say cos 37 degrees is equal to adjacent over hypotenuse equals x over 5. It implies that x is equal to 5 cos 37 degrees. Now you may use your calculator to get what the value of this is, and that will be to 3. You may put to 1 decimal place or to the nearest whole. From all indications from what you have here, this looks like this to the nearest whole, this also to the nearest whole. So you may express it to the nearest whole also when you use your calculator to find this out, and that gives you the answer. In essence, you may be given all the interior angles of a right angle triangle technically, and you may be told to find, you may be given only one side, the length of only one of the sides, and you will be told to find the length of the remaining two sides. So by the time we obtain this, we can go further to identify the relationship that exists between this side which is opposite and this side which is ordinarily given. This is hypotenuse. So we will still have applied sine 37 being equal to opposite over hypotenuse if we were told to find it, and we will still arrive at the solution this way. In an exam, one may be given something like this. Find the size of the angle labeled theta in the figure below. And the second question, the length of y. Okay. Here we are given two of the sides, but we are told to find two of the interior angles, or one of the interior angles. But the moment we get one of them, technically we have all of them. So what do we do? The first question suggests that we find this angle. So we now come here to say, first we label the sides, identify the sides. It's very important. This is hypotenuse, this is adjacent, and this is opposite. So having identified the sides, the first thing we should do, or the next thing to be done, is to identify the ratio that connects these two given sides. This is adjacent and this is hypotenuse. Definitely the ratio that connects them is cosine. So we do cos theta is equal to adjacent over hypotenuse, characteristically equivalent to 4 over 5. Cos theta is equal to 0.8. But because it's supposed to be 4 decimal places, if you like to put it, if you don't, you leave it. Because the zeros behind it are insignificant after all. Theta now, or cos inverse of 0.8 is equal to theta. So you may use your calculator to find the cos inverse of 0.8. And that is going to give us the angle here. Having said so, every time we have two of the sides of any right angle triangle and we are looking for the third side, particularly if we are not the one that calculated it, because it's always advisable that you make use of the values that you are given when solving any mathematical problem, rather than proceeding with the value that you calculated, if possible. That is just in case there is any mix-up in your steps, so that the result of the second step will not be affected by the error that was committed earlier. In this case, however, we have 5 and we have 4 here. So it is advisable that we apply Pythagoras theorem. And what is Pythagoras theorem? Pythagoras theorem states that the square of the hypotenuse of any right angle triangle is equal to the sum of the squares of the remaining two sides. That is, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. So the hypotenuse is 5, so 5 square will now be equal to 4 squared plus y squared, and this is 25 being equal to 16 plus y squared. Y squared is equal to 25. If this one comes to meet this, it becomes negative 16. Y squared is equal to 9. Y now is equal to the square root of 9. That's the positive square root. That's because we are dealing with length, which is equal to 3. So y is equal to 3, and the angle here can be calculated. Usually it's within the neighborhood of 37 and or 53. I don't know which one. That is by reason of my interaction with the Pythagorean triple 3, 4, 5 on the sides of right angle triangle. Okay, so basically this is about all that you need to understand in the as far as basic trigonometry is concerned. Now there are some applications of, don't forget I have always mentioned the fact that this is at basic level. I was with a candidate, I think within the week or over the weekend or so, and she was trying to apply sine rule. It's like using a pistol to kill a mosquito. If it is at basic level, Pythagoras theorem and trigonometric ratio, which is SOHCAHTOA, is all you need if you are dealing with right angle triangles. So this is about all that needs to be explained. The applications now are in angles of elevation and depression. Angles of elevation and depression happen to be angle between lines that produce alternate angles, in which case every problem that results from angles of elevation and depression will produce, the shape that will produce will be a right angle triangle. So bear in mind that most of the concepts just bear a very big name, but the moment you understand the basic concept, particularly when it is emphasized, because I try as much as possible to emphasize interconnected concepts, and every semantic that is related to it, I try to break it down so that we don't just begin to think that these concepts are that mysterious. But when it comes to trigonometry, this is it.